The substances which cannot regain its original size or shape after the removal of deforming force is called as plastic substance. The word stress is also very much familiar to all of us, but this stress we are studying here is with respect to the behavior of materials. Here the forces are acting away from the faces, that is away from cross-sectional area, and the force is normal to the cross-sectional area, which results in causing tension. Hello everyone, this is Swati, Faculty of Physics, Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. Dear students, today we are going to start the second part of your physics, in that the very first chapter, Mechanical Properties of Solids, that is chapter 9. I have introduced you the syllabus in my previous session. As I told you, your physics subject is having two parts, part 1 and part 2, and this is the first chapter under part 2 we are discussing today, that is Mechanical Properties of Solids. So in this chapter, we are going to discuss about some interesting application based concepts such as elastic behavior of materials, the stress of materials, strain caused due to stress, and also very important laws like Hooke's law, and we are going to study about stress strain curve, in which we are going to analyze how does the material behaves when the stress is applied to a material, and various practical applications in the chapter called Mechanical Properties of Solids. The elastic behavior of a material plays a very important role in engineering concepts. Such as in constructions, we must know the elastic properties of materials like steel, iron, as well as the concrete, and so that based on our requirements we can go and select the materials. And also we may also think like, can we design a artificial limb which is lighter but stronger? And we all observe the railway tracks in our daily life. Why the track of a railways is always with a particular shape? We may all observe that the tracks will be of I shape. Why it is so? And we can also think about the pillar design. We can think that what kind of design of pillar we can select in our buildings so that it will give long life to the buildings. So all these questions we can find a solution starting with basic knowledge of solids structure as well as behavior of elastic materials and also properties of plasticity and etc. So all these concepts we are going to study in this chapter called Mechanical Properties of Solids. So before studying this chapter in detail, let us go through some introduction part. So to understand the elastic behavior of materials and also the plastic behavior of materials, how does the material behaves on the apply of external force, we must have some basic knowledge. So to study about all those things, let us begin with an important concept called rigid body. So what is a rigid body? A rigid body generally means a hard solid object. A rigid body means a hard solid object which is having a definite shape and size. But a rigid body can be bent, it can be stretched, it can be compressed when a sufficient external force is applied on it. So rigid body means it will be having definite shape or size is what we are defining. It can be bent, it can be compressed, it can be stretched when we apply an external force on it. So which means no body is perfectly rigid in nature. We are going to study various properties of rigid body. How does it behave when the external force is applied? How does it behave when the external force is removed? So all these concepts in our upcoming slides. So we have one more important concept, the basic concept we have to understand is deforming forces. What do you mean by deforming forces? A solid has a definite shape and size. In order to change the shape or size, we have to apply the external force. If I want to change the shape or the size of a body, I must apply some external force. So this external force which will try to change the size and shape of a body are called as deforming forces. Deforming force means external force applied to a body which will try to change the shape and size of a body. That force is called as deforming force. The name itself says deforming, which means destroying or changing. So deforming means changing. The force, the external force required to change the shape and size of a rigid body is called as deforming force. So the next concept is restoring force. Look at the names, children. As the name, physics is so easy to understand because the name itself defines what is the meaning of the thing. What is the meaning of the concept? So we have restoring force. Now we know deforming force, which means the force which is required to change the shape and size. And restoring force is telling that the object can restore its original properties. The force which is required or the force which tends to regain the original properties of the material or of the object, they are called as restoring forces. Yes, the internal force developed within the body which will tend the object to regain its original size and shape is called as restoring force. The force which is developed inside the body which will tend the object to regain its original size and shape is called as restoring force. Now I hope you got the difference between restoring force and deforming force. Don't get confused. Deforming force is an external force applied on the object to change the shape and size of the object, whereas restoring force is this force which is developed inside the object which will tend the object to regain its original shape and size. This is the major difference between restoring force and deforming force. Yeah, within elastic limit, restoring force is equal to deforming force with negative sign. Observe carefully, because deforming force is the external force what we apply to the object to change its size or shape, but restoring force is the force which will develop inside the object which tends the object to regain its original shape and size. So here we are applying deforming force to change the size or shape, that is in one direction, and the restoring force is developing inside the object which will tend the object to regain its original shape or size, that is in the opposite direction. So we can represent this with the negative sign. So I hope it is clear to everybody. Elastic limit means the point up to which the material can behave like an elastic material where it can regain its original size or shape. Beyond that, it will get deformed. So within that limit, within elastic limit, one condition is applicable, that is restoring force is equal to deforming force with negative sign. So next, we are going to study about one important behavior of a material, and that property is called as elasticity. So the word elasticity is very much familiar to all of us. We know what is elastic material, what is the meaning of elasticity. So we are going to study about these concepts with respect to the behavior of solid materials in this chapter. So our next concept is elasticity. So the property of a body by virtue of which it tends to regain its original size and shape when deforming force is removed is called as elasticity. Just imagine you have one rubber band. So elastic in the sense, we know it is nothing but stretching concept, right? You have a rubber band in your hands and just try to pull the rubber band. What happens? It will get stretched, correct? So the property of a body by virtue of it tends to regain its original size and shape after the deforming force is removed is called as elasticity. And I have a rubber band, I am trying to pull the rubber band, that means I am applying some force. See, this is a rubber band and I am applying some deforming force in these directions. What happens? The rubber band will get stretched, correct? So here the deforming forces are applied. So what happens if you leave your hands? Which means if the deforming force is removed, what happens? The rubber band will come back to its original position. It will regain its original size or shape. It will come back to its original shape. So that property of material is called as elasticity. I repeat, the property of a body by virtue of which it regains its original size and shape after the removal of deforming force is called as elasticity. Just imagine you have a rubber ball and try to push the rubber ball inside. So what happens? It will get deformed, means it will change its size or the shape of the ball will change. So what if you remove your hand, or what if the force applying on it is removed? What happens if the deforming force is removed? The ball will tend to regain its original size or shape, and that property is called as elasticity. I hope it is clear to everyone now. The body which can regain its original size and shape when the deforming force is removed is called as elastic body. So when the deforming force is removed, the body can regain its original size or shape. That body is called as elastic body. And the property of regaining its original size or shape after the removal of deforming force is called as elasticity. I hope it is clear to everybody. And next concept is plasticity. Plasticity is just opposite elasticity. So what is the meaning of plasticity? What does this concept says about? The property of body due to which it does not regain its original size and shape when the deforming force is removed is called as plasticity. Plasticity is the property of a body which does not regains its original size or shape after the removal of deforming force is called as plasticity. And the material which will not, or the objects which will not regain its original size or shape after the deforming force is removed is called as plastic substances. The substances which cannot regain its original size or shape after the removal of deforming force is called as plastic substance. Now, it is very clear what is elasticity property, what is plasticity property, and what are elastic materials, what are plastic materials. So, our main intention in this chapter to understand the behavior of the materials by knowing the properties like elasticity and plasticity and etc. So, now I told you about rubber ball and the elastic rubber band examples for elasticity. Let us understand what is plasticity with one example. See, I have a clay pot, for example, or a mud pot. So, if I apply external force, that is the deforming force on this pot, the pot will get break. If I apply a great force, a more force on it, the pot will get break. But what if I remove my force? What if the deforming force is removed? Will the pot regain its original shape or size? No, right? It will get break. It will not regain its original shape or size. Whereas the rubber ball or the elastic rubber band, after the removal of deforming forces, they were regaining its original shape or size. Here we can say it will get break and it will not regain its original shape or size. So this property is called as plasticity. And the substances like this, like mud, clay and porcelain, like this, they will not regain their original size or shape after the removal of deforming forces, and those substances are called as plastic substances. So the next concept is elastic behavior of solids. How solids behaves like elastic materials. What is the reason behind it? So let us say that we know in solids each atom and molecules are closely packed. They are tightly bounded with each other. What is the reason behind this close packing? Who is helping this atoms or molecules to pack so closely? That is nothing but the reason behind this is interatomic or intermolecular force. So in solid, each atom or molecule is surrounded by neighboring atoms. You can observe this diagram. We can see this atom, each atom and molecule is surrounded by neighboring atoms. They are held by interatomic, or we can say intermolecular force. So when an external deforming force is applied, the atoms or molecules are displaced from their equilibrium positions. So let us understand this with the help of this diagram. Observe this diagram where you can see the solid like structures. Let us assume this as atoms. And we can see the spring like structure over here. And let us assume this as interatomic force. Because of this only the solids or because of atoms of the solids are held together. The force which is helping the atoms or molecules to held together is called as interatomic force or intermolecular force. Let us assume the spring as interatomic force and these solid structures as atoms. So, this point is saying that when external deforming force is applied, the atoms or molecules are displaced from their equilibrium positions. What is the meaning of equilibrium position? Equilibrium position is nothing but the mean position, their original position. So, this is the original structure of the solid. Now, just imagine I am applying some external deforming force. I am applying some external deforming force on this. Let us say here I am applying some external deforming force. So, what happens if I apply the force and I will try to pull this, I will try to stretch this. If I try to stretch this, since it is bounded by interatomic forces, all the atoms are connected with each other. If I apply some external deforming force and try to pull this, what happens? The solid structure will change its shape, isn't it? If I apply force here and try to pull this, the original shape of the object will change, definitely change. What? If I apply the force here, the original shape of the body is changing, correct? So, what if I leave the force? What if I take back the deforming force? What happens? Next, when the deforming force is removed, the interatomic forces try to bring them back to their original positions. So, yes, just imagine I have applied the deforming force and the observation is the material, the object changes its shape. If the deforming force is removed, if I stretch like this, shape will change. If I leave my hand, which means the force will be removed. And what happens? What is the observation? These interatomic forces, which are spring-like structures in the diagram, which will help the atoms or the molecules to come back to their original places, right? The intermolecular force, the interatomic forces try to bring them back to their original positions. So, hence, the body regains its original shape. I hope it is clear to everybody now. If the deforming force is applied, the object will change its shape. If the deforming force is removed, the object will regain its original shape. That is due to intermolecular or the interatomic forces. And because the interatomic forces bring back the atoms to their original positions, the material regains its original shape. And the material and those materials which regains their original shape or structure are called as elastic material. So, this is what the elastic behavior of solid says. So, the next interesting and important in the study of mechanical properties of solids, understanding the concept called stress is very, very important. The word stress is also very much familiar to all of us, but this stress we are studying here is with respect to the behavior of materials. So then what is the definition of stress? What does it mean? It means the restoring force developed per unit area of a body. We all know what is the meaning of restoring force now? Yes, the restoring force developed per unit area of a body is called as stress. So, let us write the mathematical expression for stress. If F is the restoring force and A is the area of cross section of a body, then stress is defined as restoring force per unit area, that is F divided by A. So, stress general formula is force per unit area, F divided by A. So, the SI unit of stress is very, very important. Examination point of view, this is very important question. What is the SI unit of stress? So, the SI unit of stress is Newton per meter square, or we can also write Pascal. While writing the unit, you must understand, if you write full Pascal, it should start with the small letter, which you have already learnt in the chapter called units and dimensions. And if you are writing it symbolically, then P must be with a capital letter, since it is named after a scientist. So, the SI unit of stress is Newton per meter square. How do we get this Newton per meter square? What is the unit of force? So the unit of force is Newton, and what is the unit of area? It is meter square. If the meter square goes to numerator, you will get Newton per meter square. So remembering the SI unit of stress is very easy. The SI unit of stress is Newton per meter square or Pascal. And the dimensional formula for stress is M L to the power minus 1 T to the power minus 2. You can obtain this with the help of this formula, force per unit area. Once again, you have already learnt in the chapter units and dimensions how to write the dimensional formula for quantities. So stress is a vector quantity which has both magnitude and direction. Next, we are moving on to one important concept, that is types of stress. Now we all know what is the meaning of stress. It is the restoring force developed per unit area, right? So now we are moving on to one important concept, that is the types of stress. Understanding what are the types of stress gives major idea to understand the behavior of materials. So the stress is classified into three types, that is normal stress, tangential stress or shear stress or shearing stress. The other one is hydraulic stress or volume stress. This is also called as bulk stress. There are three types of stress. One is normal stress, sometimes it is also called as longitudinal stress, normal stress, tangential stress or shearing stress, hydraulic stress or volume stress or bulk stress. So this normal stress is again classified as tensile stress and compressive stress. Understand? Stress is basically classified into three types: normal stress or longitudinal stress, tangential stress or shearing stress, hydraulic stress or volume stress, or we can call it as bulk stress. So normal stress is again classified into two types, that is tensile stress and compressive stress. So let us understand what are these types one by one. So the first one I have is longitudinal stress. The term longitudinal refers to length. This is what you have to keep in mind to understand the concepts or to recall the concepts while the preparation for examination. Longitudinal stress is our first type of stress, that is also called as normal stress, correct? So the restoring force developed normal to the surface area resulting in change in length, then the stress is called as longitudinal stress, which means the force, the restoring force. We know the basically stress is defined as force per unit area. That is the restoring force per unit area. So if the restoring force is developed normal to the surface, for example, so here you can observe this diagram. Here the force is acting normally to the surface. So what is the result of this application of force? It will change the length of this object because it will get stretched. So if the restoring force is developed normal to the surface area, which results in change in length, then such kind of stress is called as longitudinal stress. So longitudinal stress can be written as restoring force divided by area, and the formula for this is F by A again. Since it is also a type of stress, stress formula is also restoring force by unit area, that is F divided by A, and longitudinal stress can also be defined as F divided by A. So next one, as I told you about the classification, there are two types of longitudinal stress. One is tensile stress, the other one is compressive stress. What do you mean by tension or tensile stress? Tension is nothing but the pulling force, right? So tensile stress is related to that concept. So tensile stress is nothing but the normal force which is acting away from the faces on which they are acting. Then the longitudinal stress is called as tensile stress. If the normal force, you can observe this diagram now. Here the normal force is acting away from the faces on which they are acting. So this is the face on which the force is acting. They are moving away from the face. Then such type of longitudinal stress is called as tensile stress. because of this acting, because of the forces are acting away from the faces, there is a creation of the tension in that particular object. So because of that tension, the length of the object or the length of the material will change, the length will increase. So if the forces are acting away from the faces on which they are acting, such type of stress will result in change in the length, and that type of stress is called as tensile stress. And similarly, the exact opposite behavior of the tensile stress is compressive stress. We are all familiar with the word called compression, right? So what is the meaning of compression? If I have a spring and if I apply some force in the opposite direction, what happens? The spring will compress. It will change its length, correct? So the spring will compress. So again, in this example also, the length of the spring is getting changed, which means there is a longitudinal stress, right? So that is a better example to understand compressive stress, and it says that if the normal forces acting towards the faces on which they are acting, then the longitudinal stress is called as compressive stress, which means, look at this diagram now. This is the object. These are the two faces, face 1 and face 2 of the object, and here the normal stress or the normal force is acting towards the faces, correct? Here I am applying the force in this direction. The forces are acting towards the faces on which they are acting, which results in the compression of the material, which means the length of the material will decrease. So such type of stress is called as compressive stress. I hope it is clear. Let me recall once again. Tensile stress is the type of longitudinal stress where the normal forces are acting away from the faces, which results in change in length. Generally, the length will increase because of the tension. And next, compressive stress is nothing but a type of longitudinal stress where the normal forces are acting towards the faces, which results in decrease in the length, which means there will be a compression of the material, and such type of stress is called as compressive stress. For example, here I have an example to understand the tensile stress and compressive stress. If a cylinder is stretched by two equal and opposite forces which is applied normal to its cross-sectional area, then the restoring force developed per unit area is called as tensile stress. For example, I have a cylinder over here. Look at this. So this area is called as cross-sectional area. This area is called as cross-sectional area. If this cylinder is stretched by equal and opposite forces, you can observe here I am applying a force which are equal and opposite. This is the initial length of the cylinder. Initially, the length of the cylinder will be so much. And if the equal and opposite forces are applied normal to its cross-sectional area, you can see here, this is a cross-sectional area, and the force is applying normally to this cross-sectional area, then the restoring force developed in this object per unit area is called as tensile stress, because as we know, stress is nothing but force per unit area. So we can define tensile stress as the restoring force developed in this object per unit area is called as tensile stress. So what happens if two forces are applied in the opposite direction? The cylinder will get stretched, and hence the length of the cylinder will increase. So which means after the removal of deforming force, the material will regain its original property, and the force which is responsible for this is nothing but the restoring force. So the amount of restoring force that develops per unit area in an object is nothing but tensile stress. Here the forces are acting away from the faces, that is away from cross-sectional area, and the force is normal to the cross-sectional area, which results in causing tension, which results in causing the change in length, which means generally the length increases. So such type of stress is called as tensile stress. And if a cylinder is compressed under the action of applied force, then the restoring forces developed per unit area is called as compressive stress, which means if I have a cylinder like this and this is a cross-sectional area, I am applying the force, equal and opposite force in exact opposite direction what I have applied, what I have shown in the previous example. So what happens if the force is applied in the opposite direction? The initial length will change to some other length, call it as delta L, because there will be a compression here. the material will get compressed. So, when the material compresses, the restoring force developed in it and the restoring force developed per unit area is called as compressive stress. So, longitudinal stress are of two types, what I have explained. One is tensile stress, the other one is compressive stress. So, on a whole, what we can understand from this is longitudinal stress results on the change in length and shape. So, in any kind of longitudinal stress, whether it may be a tensile stress or a compressive stress, what happens? If I apply tensile stress, the length will increase, the tension force will be applied and the length of the material will increase. If I apply a compressive force, the length will decrease. So, generally, longitudinal stress results in the change in length and shape of a body. This is all about the first type of stress called longitudinal stress. And next we have tangential stress or shear stress. As I told you, longitudinal is the word refers to length, which means we observed that tension and compressive stress, tensile and compressive stress results in change in length. So now similarly, tangential stress or shear stress tells that the restoring force developed per unit area. One thing is common over here, restoring force developed per unit area, because we are talking about stress and stress definition is restoring force developed per unit area. We are discussing about the different types of stress. So that is the reason why we are defining every stress, every type of stress with the same thing, that is the restoring force developed per unit area due to the applied tangential force. You have to keep in mind, you have to understand, application of tangential stress results in the developing of restoring force per unit area is called as tangential stress. I repeat, restoring force developed per unit area due to the applied tangential force is called as tangential stress. You can observe this diagram. Here we are applying some force on this area tangentially, which means what happens if you apply the normal force, you can observe the relative displacement of one surface with respect to the other surface. Observe here carefully, you are applying some force. We can also experience this in our daily life. Hold a notebook and try to push the front surface of the notebook. You can relatively observe that the relative displacement of the bottom surface in the opposite direction, exact opposite direction, which means it is also causing the change in its shape, the change in the shape of the book, because I am applying force in one direction, which is causing the movement of the surface which is there in the bottom in the other direction. That is called as the relative displacement. You can observe, you can just try this also, and the restoring force developed per unit area during this example is also called as tangential stress. So here you can observe, we are applying force here in this direction. It is one face is moving in this direction, and you can also observe at the same time the relative displacement in the opposite direction. So because of that, there will be a small change in angle. So you can observe force is applying in this to this surface, so it is getting displaced. As this gets displaced or this changing its position, the bottom layer also will change its direction. It will move in the opposite direction. There will be a relative displacement between the two layers. That is because of tangential stress. So if tangential forces are applied to the opposite faces of a block, then there is a relative displacement between the opposite faces. A very clear example for this is, hold a notebook, try to push the first upper layer. So what you can observe, the bottom layer will also gets relatively displaced. That is called as tangential force. So generally tangential stress is defined as the restoring force developed per unit area due to the applied tangential force is called as tangential stress. So tangential force is nothing but they are applied to the opposite faces of a block. This is the second type of stress, that is tangential stress or shear stress. So next one we have is hydraulic stress or volume stress. Hydraulic or volume stress. I told you about longitudinal stress where we observed the change in length. Next one, tangential stress, where we observed there will be a relative shift, that is we could observe angle that because of this relative change. So second one is a tangential stress, where we observe the relative displacement of two layers. And then third one is the hydraulic stress or the volume stress. It says that when a body is compressed uniformly from all the sides by application of deforming forces, then the restoring force per unit area of a body is called as hydraulic stress or volume stress. For example, you have a body over here. You can see here the deforming force is applied in all the directions, correct? So if the body is what happens if the deforming force is applied from all the directions? The body tends to compress. The body tends to change its volume, correct? So the body is compressed uniformly from all the sides, because here the deforming forces are applied in all the direction, which results in the compression of the body uniformly in all the sides because of the application of deforming force. And that time the restoring force will also develop in the body per unit area, that is called as hydraulic stress or volume stress. As in case of longitudinal stress, there will be a change of length. In case of tangential stress, there will be a relative displacement, change of angle. And here in case of volume stress, we can observe the change in volume. That is a uniform change in volume due to the application of deforming force from all the directions, which results in the compression of a body. So let us understand this hydraulic pressure concept by taking one example. When an object is placed inside a fluid, the fluid exerts a normal force on the surface of the object. So for example, if this is an object, let us say, whose volume is V. So I am placing this inside the liquid. What happens? The liquid molecules will exert force on this object in all the directions, correct? On the surface of the object, the fluid is exerting some force. So what happens if the fluid is exerting force in all the direction? What happens to the object? The object's volume will get decreased. So initially the volume of the object was V, and after the application of deforming forces, the volume becomes V minus dV. It will become less. So the volume of the object decreases. The force applied per unit area is called as hydraulic pressure. We know what is pressure. Pressure is also nothing but force per unit area, correct? So we are defining hydraulic pressure, which means if the object is kept inside the fluid exerts force on the object from all the direction, which results in the compression of the object, which means the volume of the object will decrease usually. So this force applied per unit area on the object is called as hydraulic pressure. So if you know the concept of hydraulic pressure, understanding hydraulic stress is again very easy. When hydraulic pressure is applied, internal restoring force developed per unit area of an object is called as hydraulic stress, because stress is nothing but restoring force per unit area. So when a hydraulic pressure is applied, the internal restoring force developed per unit area is called as hydraulic stress. So we have studied about the types of stress. What is stress? What are the classification of stress? I hope it is clear to everybody now. Let us recall what we have studied in today's session. So we have studied about a rigid body, which means a solid object which is having definite shape or size is called as rigid body. And we also studied about elastic behavior of materials, how the materials behaves elastically. By taking an example of interatomic forces, we have studied about the elastic behavior of solids, and we have studied about elasticity, the property of a body which can regain its original shape or size after the removal of deforming force is called as elasticity, and the material or the substances that can regain their original shape or size after the removal of deforming forces are called as elastic materials. And also we have studied about plasticity. Plasticity is nothing but the property of a body or an object that cannot regain their original shape or size, that cannot regain their original properties after the removal of deforming forces, and the property is called as plasticity, and the substances or the material that cannot regain their original properties are called as plastic materials. We have also studied about the deforming force and the restoring force. Very basic and important concepts. We have studied about stress. Stress is nothing but force, the restoring force per unit area. You can remember this formula, F by A, and the SI unit of stress, that is Newton per meter square. And also we have studied about the classification of stress, that is normal stress, tangential stress, or shear stress, and bulk stress or volume stress. Also, I have told you about normal stress is again classified as tensile stress and compressive stress. As we have three types of stress in the study of mechanical properties of solids, we even have a concept called strain. What is strain? And also strain is also classified into three types. What are the types? Many more interesting concepts we are going to study in our upcoming sessions. So until then, take care all of you. See you all in the next session. Thank you.